More Volatus time. It's kind of a bit going on here. We'll walk through it. But I am going to be making a new capability. So right now I have these kinds of controls. They look like a numeric indicator control inside of a button. That's basically what they are. But I can click this. I get a prompt. Let me change the one that's actually doing something right now. So now this is controlling the timing of the automation feature that this is turning on or off. So I could turn that off, turn it on. So now every half a second, it's firing this thing, which fires this one, then fires this one after the specified delay. This is all configuration driven. So in the system configuration file, I've got this digital control module that is running in a separate application for this GUI. There's actually two applications running here that I run with these top level VIs that kick off the application. There's the DACMX, which is working with a simulated CDAC chassis for the I/O. So you can see my simulated CDAC I/O in here. So there's digital outputs. We've got analog outputs. I'm effectively using these as software variables right now because I don't have that capability yet. And then analog inputs. So just the normal sine wave that you get. It is getting scaled. So this is also demonstrating scaling. But yeah, so all of this, the analog, the DACMX stuff is running as one application that includes the control stuff. And then there's this GUI app. I can close this GUI app and just that window goes away. Rerun the GUI app. It's back up, restores state. Everything's picking right back up where it was. Yeah, so I want to add a new capability. I've got these numeric controls which let me, enter a specific value to set something to. But what if I want something like a slider? So what I would like to do is, if I open this up, is I would like to be able to have something like this and have that be interacted with. What am I looking for here? The text color, make that off-white. And I want to be able to, so the way all these work is their documentation description links them to a channel. And anytime that is changed, there's code running behind the scenes that sends a command to the system to the application responsible for this channel, and that would get changed. There's also a type field that binds it to a specific GUI element implementation, which then understands the rest of the configuration and how to make it work the way it should work. And the reason why it's not hard coded depending on the typedef type is because these actually aren't linked to typedef because these load dynamically at runtime, and getting the typedefs to link properly when you're dynamically loading stuff is a bit of a pain. So they're not typedefs. They're just regular controls. They do have a control file. This is one of the rare occurrences I've changed something from a typedef back to a regular control ever since they made typedef the default. But it's really handy here. But the idea is that you could have a GUI front panel element that could have different behavior attached to it. So it still looks the same, but maybe sends a different type of command. Maybe this one would send the analog command to change a numeric value. Maybe another one sends an HTTP request. So you could decide what behavior it's going to have based on this type field. And then there's a bunch of other optional stuff typically. So I want to be able to do something similar. So again, the way these get linked up is we need, when it is, the configuration is in these controls, I am also going to be implementing a way to have that in the config file that's in the VS Code in the background. But we need that special GUI tag, and then I'm going to set the type, and this is just going to be a basic double control. So it's going to be a double representation for a numeric. and we want it linked to a single channel. And I don't know what channel this is going to be yet, but we could fill in some property. Let's actually make it. Let's make it the heater set point. So what was your tag? Heater _1 _ set point. Let's just tag onto that same value for now. And give it a label. That label actually collides, which would be a bit of an issue, but maybe not. Let's have this set point just for now go from 0 to 5, and we're gonna make that work. So if I run this, so we've got this heater set point that integrator has wound up fully. So I could change this, and we can see it's affecting the heater output. You can see this Boolean is showing whether the heater is actually on. It's doing, like a 3 or a 5 second pulse width modulation, where a 5 second pulse width period PWM modulation. And as this ramps up, we'd see this Boolean stay on for longer and longer. And in this generic display, you can see the heater enable periodically come on for a period of time. This brighter green line is this 0 to 1 output, and then the lighter green is the actual Boolean output that would presumably get hooked up to be configured, mapped to a digital output channel. That would be triggering some solid state relay, driving some AC heater bands or something. But I want a slider to change this number instead of having to always type it in manually, just to demonstrate the capability. The other nice thing with how this GUI framework is implemented is as I change this one, this guy will update, and if I implement this one properly, as I change this digital control, the slider will update as well. So let's go ahead and get that started. So I'm going to close everything down. And one of the first things I like to do is start with what the config is going to look like. So this is going to be, oh wait, no. I'm crossing two videos I want to make. The other video I'm going to be making soon is for implementing bang bang control. We're doing GUI right now, so that has nothing to do with that config. So the way the GUI works is there's a handful of classes, and there's going to be more and more and more over time. So like that digital pop-up control was this class. It's got a override VI that defines what the string that identifies it is. In a lot of situations, you might see something where they just do the class name and strip off the .lv class. And that is a form of regular expression. And this is a common thing that gets done a lot. However, if you ever refactor and change your name or change the class's name or anything like that, now all of your existing configs are completely borked. So I don't like doing this pattern because it ties your configuration to your source code too directly. But that's, for now, that's basically what I'm doing by hand is using the class name. But I might have to reorganize it. Also, the class name includes the library that it's in, and if you move stuff between different libraries, that also invalidates as you reorganize and refactor things. So I generally just tend to avoid that as much as possible these days. I'll always have a dynamic dispatch override that provides a string value that I care to map to. So we're going to be making one of these. The basic operation is there's an initialize VI that gets called, and that's where it can get the reference. So the framework is going to traverse all the controls on the front panel, see if it's got that little GUI tag in the description. If it does, it grabs the JSON that's after the GUI tag and will look at the type field, and then everything except for the type field, well, actually the type field gets passed in as well, but the framework only cares about that type field, uses that to look up which of these classes it should factory pattern, the factory method pattern, and then calls this init vi so it can initialize itself. So it's going to turn that JSON into stuff. A bunch of stuff might be optional, so we're checking to see if that value is set or not. If you edit the properties of the control in LabVIEW itself, there's no reason why that should get overridden. However, for in the future, when this JSON is coming from the config file itself, maybe we do want to override what is configured directly in the front panel. So what I'm talking about is, where's my scratch? Not that one, this one. If I change these off colors to like a dull yellow, and then the on color is the green, maybe I want that to stick and not have to specify it in its description configuration. But yeah, so initialize, it'll do stuff like get the objects that store updates to the values that the element is updating itself from. Any kind of asynchronous behavior it needs, like the pop-up prompt. The GUI module is continually looping over all of the controls, seeing what events get triggered, and if one of those, the event handling code, stops with a pop-up and waits for that pop-up to be, accepted or canceled, it's not doing any of the rest of the GUI stuff. So when we're doing pop-ups like that, those controls launch an asynchronous VI, which includes this one. This is the one that has that numeric prompt as a pop-up. It launches that prompt asynchronously, and then that state gets fed back through this notifier if they don't cancel. Most other stuff that doesn't have additional pop-up prompts isn't going to need to worry about any kind of asynchronous behavior. So this is just the case for handling that situation. Most of these controls, and this is not going to be the case for the control I'm implementing right now, are in fact, if we look at the context help, a cluster with multiple elements in them. So for instance, this double numeric control, I've got a button in the background just as the backdrop. It's actually disabled, if I'm remembering correctly and set it up correctly. Yeah, so it's disabled. So the button isn't what's working as a button, but it is in there just to give that recognizable beveled edge. It's got a color and then a value. So this black outline outside of the white outline is in fact a color box, and we can reflect status of the system with that. Like there was an error, or there's a configuration issue, or the data is stale and not getting updated frequently enough or at all. So that's a way for me to embed a bunch of information around this without taking up much more room. So it's not an individual element, and that's why in this initialization code, we could see we're getting the top level reference, and that is the thing that has that configuration in the description. Casting it to a cluster, because this class expects to operate on that control. Gets the nested controls under there, knows that the numeric control was index 1. Near as I can tell, if you look in the context help, the control indexing in a cluster always follows the order of the elements that are in there. So index 0 would have been the color box, index 1 is the value, index 2 would have been the backdrop, but we don't really care about those in this instance. But get the numeric control out, and that's where we can set anything that is configured in the configuration. We can apply those properties to it. But generally, again, the main thing is getting the group that the data comes in from, and then the channel within that group that has the value that represents what we're doing. If there's any initialization errors, storing, a config boolean. If that config boolean is true in the other code where we'll be updating the value for it and doing the GUI feedback. If that config flag is set, that's when we set that color box color to magenta. Next in the list is the events VI. If this is overridden, you can request to register for a handful of events. Now, with this double pop-up, the way the event, the term in web development is like event bubbling and event propagation. It seems to kind of follow at least similarly enough that we can register an event on the cluster itself for mouse down, and no matter where in that cluster you click, it will fire mouse down for that cluster. So that's all we're doing here. With some of the other controls, we might be pulling out like a hidden button that is in front of everything, and then is going to capture value change events. And that's actually how the valves work. So on this, I'm pulling out the command control inside of the cluster. So here, this was before I realized they were could be consistently indexed. Or if you want the flexibility of it not needing to be that specific cluster, and as long as it's got the same name, this would be the better approach to use. So I'm still 50-50 on which direction I'm going to make standard. But we could pull out one of the nested controls inside of the cluster and register an event specifically for that one. Now, initially, these are just VIs that build up an array of what events this control, this GUI element cares about. And then the framework later on is going to collect those and build up the event registration for that, and it handles the events itself. That way, all the event handling is nice and centralized. For each of the events, there is some specific interfaces for what type of event it is. So like with on click, actually I don't have that one implemented. On mouse down. So these are all of the data you can get from the event. It's just that we're going to dynamic dispatch into a class. This is the base class, so it has no functionality. But the two that are implemented right now are on mouse down and on value change. This is probably the most common event, value changed. You'd see the old value, the new value, the control reference, all that fun stuff. And all of these pass in this API object, which exposes the entire application functionality anywhere that API class is available. So any of these GUI element classes can basically do anything that's available in the entire application framework. And then an example implementation of that. Let's just keep focusing on this Boolean, on this double numeric control. Is it's handling mouse down, so here's that same front panel. And this one is launching that asynchronous VI, so it can get the numeric prompt. And if it's canceled, it does nothing. If it's not canceled, it sends the command. So this is going to set up the remote messaging command to that looked up application and the task that owns that channel. If that succeeds, well, whether it succeeds or not, we're just updating some state information and storing that in that notifier. So we're basically using a notifier as a not global, but a scoped by reference variable. Other ones will have different behavior in here, of course. So that's the events for that. And then the last VI is update value. This is called at the update rate of the GUI, which is a configuration field. So if we look at the GUI here, there's this refresh timeout. So if the message queue for this plugin GUI module times out, it then does a refresh iteration on the GUI. And this is where we can do all of the state management. And then all we're doing is just basically creating the value that's going to get um, written to the control. We could do some filtering. So if there aren't updates to this element, we could choose to, compare against what we previously generated and tell it to not bother updating that, which could save some CPU cycles. Um, for some of the more complex elements that I have tried being smarter about whether or not they update, the all of the conditional logic to decide whether or not to update seems to decrease the performance. And just updating the GUI and doing the processing to figure out what the GUI update should be is more efficient. So for the most part, just always hard coding the update to true. If this is false, the framework isn't going to do anything with this value. It doesn't keep it. Um, so yeah. But in the case of this double numeric control, we're always reading the current value out of that notifier, seeing what state we're in. If we're in a commanding state, we're gonna temporarily ignore. So okay, here is where we're reading the current value as getting published out on the network. And most of the time, that's the value we're going to put in the indicator or in the control, actually. So we're going to refresh the control with the current value. If the timestamp from that is stale, that's when we set the cyan color. But if there were errors or a configuration error, those statuses override. So we're deciding the color box value, the numeric value, and I'm only using the button as a decoration. At some point, I should probably change that to just like an image, so it uses less resources. But we're just always setting that to false, and that's how the GUI always reflects the current state of the system. However, if we've told it we want it to set it to a new value, we don't want to immediately go back to displaying the current state, because that is going to get sent as a network command to a remote application, presumably, and it's going to take time for that to get processed and come back. It's really quick, but it's long enough that the GUI is probably going to go through an update cycle or two before the updated value comes back, and you're going to get into that situation where you see the value flip back and forth a couple of times, maybe, or like it'll flip back to the previous value, and then like on the next refresh cycle, it shows the new commanded value. So to prevent that, we've got a little bit of state handling here. So if we're in this commanding state, we're checking to see if, and this is a double, so we're not looking for an exact match, just in case, but looking for, out to the 6th decimal place, does this match? Uh, and as soon as it does match, we reset that we're in a commanding state. So this basically just turns commanding off and updates this. So after that, it'll then go back to just continually updating what the shared state says. And this way, if you've got multiple operators on separate computers operating their own GUIs and one of them changes the value, the other person who isn't in the commanding state will get that update in their GUI when it propagates through the system. The other thing we're doing is if the value coming back doesn't match yet, we're checking to see if it's been long enough. So right now I'm hard coding a 10-second timeout on all of these. I'm probably going to regret that as I get to about 100 of these GUI element implementations. But if it goes 10 seconds without seeing that updated value come back, we're going to reset the commanding status anyway. The other thing I should probably do is set like an error status in here. I'm still working out how I want to reflect that a command failed. Maybe differently than the error state, but it'll probably just end up being the error state. So some more logic will probably show up in here, or maybe in here I'll have like an error input. Oh, create control, something like this. Who said anything about scope creep in one of my videos? Kind of also trying to just introduce the concepts of the GUI framework, because the element I'm going to be implementing is pretty quick and small. And so in this case, I could do true. And then that would show up the next time it updates the GUI, it would show up with the red border until you try commanding it again. And then if that were to succeed, we'd get into this case, if the value comes back and matches, we'd get into this case where we're not setting it as an error. And so to go back to showing one of the other statuses. So yeah, that's everything in a GUI element. So basically you inherit from the base class, which is this GUI element class. That's what's going to define those protected dynamic dispatch VIs. And then if you want event interactions, you're going to implement one of the event interfaces. The number of these are going to grow as the framework starts to enable more interaction types with things. So for this numeric control that I want to do, we're going to implement, we're going to inherit from GUI element and inherit from on value change, and we're going to implement all those VIs. This one, I'm not going to be doing all of the nested status. Instead, what I can do is set like the text to magenta or set the background color to magenta on the control if it's in one of these states to reflect that. So this will be a little bit simpler on that regard. Although I guess I'm not sure if VI server is less complicated than just writing some values out to it. So this is just going to be a double. What did I say it was going to be? I put that in the GUI and then now I forgot. Go me. Just double control. Okay. And then this class list is long, so I will use my search feature that I've added to this GUI. And then down here, we're going to want the on value change handler as a parent interface. And we wait for LabVIEW to do its stuff. Now things are broken because it doesn't have its dynamic dispatch VIs. I'm going to create all of my starting folders that I like. And now we're going to make the overrides, except for that one. We do want events. Normally I make the overrides at the top level and then drag them into the correct access scope folders, depending on what they are, but I know what access scope these guys are, so I'm just going to do it this way. In 2 steps instead of 1, and then some dragging around. So first thing, set that string value for the element type. And then the event is going to be easy to set up, so we'll do that. So this is in the control event registrations, which is this class, so you could get to the automatic palette. I've been having a lot of issues with this not updating as much as it probably should, but I do know the names for it. It's add and then whatever the name of the event is. You wire in the control. This doesn't actually do anything. It's vestigial. Outside of the fact that this does guarantee that this is implementing the correct interface that is expected for that event. And it's a required input, so it just forces you to make sure you set up your inheritance properly. Now, this reference will be the slider itself, so that is what we're going to register the value change on, and this is how event hookup happens. Now, anytime the value changes, this VI would get called. So this is where we're going to put our event handling code. But we'll get to that because we're going to need to add some stuff to the class in the init to make that work properly. So I always tend to make a type def that represents the JSON that's going to be the configuration. This one is very simple for now. It's just going to be the name of the channel to bind to. But over time, it might be things like we want to, from the configuration, set the colors. So for different applications, if we're reusing the same GUI, but we have different color schemes or representing different types of values, we don't have to worry about setting that all really strictly in the GUI itself. We could apply that from the configuration. But for now, we'll just worry about the channel. We'll just get it functional and worry about the fancy stuff later. I am using JDP Science's JSON text library a lot these days. So we'll use that to turn the JSON string into this convenient cluster. And then I've got a fairly good idea of what the next steps are, but there's lots of examples here. So why don't we go back and look at that other control to see what the typical pattern is. So the first thing we're going to do is look up the channel info. So from the channel name in an entire test system, or even if not necessarily test, but in an entire suite of applications deployed to a some specific system, channel names must be unique, group names must be unique, node names must be unique. So we can look up the channel info based on the channel name, and then we're going to make sure we're subscribed to it. Right now, this does this subscribe is always going to subscribe. One of the goals of this framework is to work within a single application where maybe you're a PC application talking to a CDAC over USB or Ethernet, and so all of your DAC-MX is running locally instead of on a remote system like a compact reel or a PXI in a test rack. And in those cases, you wouldn't be subscribing to remote values. So I'm going to actually, let me check something quick because there is another VI that I wrote. Obtain group from the API. I think this checks to see if it's a local group. Yeah, it looks up to see if it's a local group. Then it checks the config to see if it's a local group. Or actually, this just looks to see if it's already created. If it's already created, we don't care if it's local or remote. We have the group, we can use it. If it doesn't already exist, we're going to check to see if it's a local group. If it's a local group, something else is going to be responsible for creating that group. So we're just going to keep polling once a second to see if that group becomes available. And otherwise, let the error... oh, I need to clear error 56 on this guy. Finding bugs while I'm recording my intro videos. Cool. So this would keep spinning. This explains why I'm not using this very much yet. So yeah, so this will poll once a second and check to see if that group becomes available. Theoretically, when something else that's responsible for creating it creates it. If it's not a local group, then we're going to subscribe to it. If it's already subscribed, doesn't matter if like 3 things simultaneously try subscribing to a thing, a warning will show up in the event log, but you'll still get the group back and it doesn't like resubscribe and all of that. So this is perfectly safe behavior here. And now will work even better that I've not aborting on the first timeout. We instead want to do our own timeout timing outside of that polling behavior. So yeah, we're going to use this instead of subscribe, and that way it's better. It's going to better handle. In fact, let me change this one to obtain group from the API. Now this double pop-up control will work whether it's a local group or a remote group. Hooray! If you can't tell, this framework is still very much in development. So yeah, so copy this guy. And so we're using the channel to effectively get the group name. And then we can get the group. In the case of, right now there's only 2 types of groups, so there's this group type input. By default, it just gives you the abstract group out. There's accessors where you could see what type of group it actually is, and maybe you're implementing code that's more abstract and flexible in what types of groups, what data types of groups it supports. This is a numeric control. We are only concerned with numeric groups, at least for now. There is actually a string group, which might be doing, string encodings, human readable versions of numbers. And maybe someday we'll make this flexible with that type of group as well. For now, we're gonna maybe, the idea is these are relatively simple to implement. I could implement a different type that is more optimized for pulling numbers out of string groups. Because that level of switching would, if we've got 100 or 1,000 of these in a GUI or across an application, that extra conditional logic would absolutely slow things down. So we'll leave that extra handling out for now, and err on the side of performance. So presumably, we'll get the group out, which we can then look up the channel. Where is, lookup channel. And any one of these could be generating an error that the channel doesn't exist, which would create an error 15 here if the group ends up not existing. If it's a local group and it just doesn't exist, we'd get in time, we'd get an error 56 because it never got created. If it's a remote group and there's an error with subscribing, there could be other errors here. If the group name doesn't exist in the config at all, we would get an error 15 for resource not found. But we'll just keep chaining this error wire along. And then I'm not going to worry about setting any properties. Again, we don't have any of that. I do actually. We do want a staleness configuration. That should be in just about everything as much as possible. So this is just going to go into the class private data. So let's get that set up. So we're going to have a channel that we read the current value from. We're going to have a staleness, timeout, and for this control, that's about it. We should also track if there was a config error. And I won't worry about commanding error yet. So we're doing the channel, we're doing the staleness, and we're doing whether or not there was a configuration error / initialization error. This would cause it, if this is true, again, we'd color some part of the GUI element magenta, and then that would be the clue that we want to look in the event log, the debug log, and figure out what the issue is. So we got to make sure information goes into the event log. So we're going to take that error and report event. Report error. Report error only reports the error if it's an error. If it's not an error, it doesn't do anything. But it automatically sets the event level, sets a timestamp, and allows us to pass some other information along. And this is going to be double control init. And then for some more context, we'll put the channel name that we're trying to link to. And this should theoretically help us, if there is an error, identify which control is misconfigured or anything like that. And usually the case will be that the channel name has a typo in it, or somebody malformed the JSON, and so this fails, which reminds me, propagate that one as well. That's it for the initialization for this element. We are not propagating this error out. This would be, maybe for the logging control, we would want to propagate that error out. Propagating an error out will cause the application to stop starting up. If it's something that's in the configuration. If it's dynamically launched later on, it depends on how whatever is deciding to launch that handles that. But for these GUIs that are in the configuration directly, these are getting launched by the core module. And if any of the things that it is launching immediately at the beginning returns out an error, everything stops. So it kind of depends on how it's getting launched on whether or not returning an error out counts as a catastrophic failure. But just by and large, we're putting it in the event log if there is an error, and letting the user know to check the event log with coloring. So we will not bother propagating that out. And then the last thing to do is, I forgot. This is going to be used for commanding. So there are some other things we need for the commanding. We need whether or not we are commanding. We need a value of when the commanding started. And now that should be good. Come on, LabVIEW. I just wanted to save the class private data. You didn't need to hang. Any day now. Maybe. Oh. There we go. Thank you, LabVIEW. So the last thing is update value. This is where we're going to do some stuff. So this time value that's coming in, if we look at what calls this VI, I did not set my class icon. And what calls this VI, we get, instead of everything having to look up the time, the idea is kind of everything's updating for that time step, which isn't quite true because some of the elements, might get newer values from the network while earlier ones are updating. But by and large, we don't want everything to have to keep looking up the time. And eventually I'm going to have more centralized time management in this application so we can get better synchronization across the logic running in distributed executables. But we don't have to look up the time in each individual GUI element, so we're just passing that in. And so we'll be using this for the staleness check. We'll be using this to see if the commanding has timed out and just go back to showing whatever the last known value was. But the other pretty simple, the digital button control actually has a relatively simple update value because this doesn't do anything asynchronous. So we're going to largely copy and paste this guy. and then update names and things as necessary. So this will be quite unhappy at first, but we'll get it there. And this was channel, that linked that up. Commanding, this was command start. And, oh, we need to keep track of what command value we're going to. So we'll have to update in the event handling code when we get to the event handling code. We don't need to change this to a Boolean in this framework. Even Booleans are represented as doubles. That sounds horribly inefficient in memory, and it absolutely can be, since they're 8 times larger than a single byte. But it simplifies so much of the rest of the application that generally I find that optimization is worth it. Time, let's get that wired in. Whoop. And error, we're just going to replace that with a false constant for now. So I kind of have that logic in there as a placeholder when I implement that, and then the config value. So we're not going to be using, obviously, a color box, because there is no color box behind this. I'm going to trust that the code in there is correct, because I know that other control works just fine. But we're always going to update to that value. I will go over it and check that in a jiffy. Whoop, that's not what I wanted to do. That's what I wanted to do. And we are going to get the control reference and set a property. I'm going to throw one of these down. First, let's make everything look similar. Let me go into the GUI and copy that control. And I'm going to play around with setting different things to different colors. I'm thinking maybe just this slider background would be a good candidate. Does that look all right as black? I mean, it's got that stupid coloring thing up top. Oh, nope, not anymore. Okay, that's weird. Let's check out an NXG slider. Maybe that one is less quirky. Oh yeah, this is better. Okay. This class behavior that I'm implementing isn't going to care what type of, like, it could be any type of numeric control. Um, ooh, actually, no, it can't be, because we're going to need to know that it's a slider to set the slider background. Justify, what am I looking for here? The text color. How does this look with a black background? Not terrible. Yeah, I'm all right with that. And we can change that to really heinous colors if there's any issues with it. And we'll just have to know that we should never have a slider that we're filling with magenta or cyan or dark red or bright red. And I'm going to rename this to SliderControl, because this is now getting specialized for sliders. And so I don't have to do that typecast, the to more specific class every time. We are going to store it as a slider reference. So I'm going to create a reference, create a constant. I'm not going to bother putting this error into this one because if this typecast fails, then we can't set the coloring appropriately. So this will just have to be an issue of does it work or not. I will merge it in with what goes into the event log. And I'm going to knee-jerk reaction say that the other configuration errors are more important than it being the correct type of numeric control. But we'll go ahead and do this funky error wire weaving. But we're just going to cache this as an actual slider reference. And then we don't have to do that to more specific class every iteration of update value. Okay, so there's that updated doohickey. And then the idea is if there's an error, make this really heinous looking. And so that would be if configuration error, if we're not getting updated values, it would do this. And I think that works. So we're going to find we're not going to use this one. We're going to use the slider. Because then I should get a property for the slider colors. Background color. Now, VI server is pretty slow, so this would probably be a pretty good candidate of keeping track of what our last set color was. And if it's the same color, don't bother writing to VI server. We'll stick with this for now. But this should be... oh, no, I lied. We haven't done the on value change yet. Value change... which one do I want to take a look at? I believe it was the valves. The valves maintain their own internal state. We're going to... Yeah, so I don't have something that handles a simple single control like this. But we'll do this. We're going to get the numeric value. We're going to send a command using the API. Oh, this is what I need to store. See, this is referring to older examples. We need that channel info. And this will be the info we use for the command, so I will name it as such. I could get that from the channel itself every time. The channel does have that accessible. However, that does require unlocking a data value reference. So we'll just cache that locally and use a tiny amount of extra memory for the contention mitigation. Okay, so now we're keeping track of the command info. This is going to give us what application are we sending the command to within that application, which task / module is receiving that command. And so command info, we want the channel name, we want the node and the task. And then we can send a remote message with the API. And we're going to do an command analog init data. So we're going to use the class form of this message. That's how some of the existing APIs work. So we're just going to create this guy. Which needs the channel name and the new value that we want to set it to. If we made it through initialization, I'm going to assume that we are in fact hooked up to a slider. So I am going to forego some error propagation and checking in this VI here because we have that reporting in that earlier VI. Now, we need to keep track of the fact that we are commanding, what value we are trying to command to, and what time we started commanding. Let's swap these around. Now, this should just work, TM. I still need to wire, yes, the message type name. And then, of course, we want to report error in the API class in case this errors. This would be where it'd be really easy to take this error status and write it into write that in as an error Boolean. So we could do some funky coloring updates. But again, we'll focus on just the quick and easy things for now. I will also show the channel name. So if this generates an error at all, this would put it in the event log. This should be everything we need for this class now. Yeah, I still need the message name. I know that this message name is command analog. And now, I think this is like the third time I said it, third time's a charm. This should be everything we need for this. So now if I run this, the slider should work, maybe. So we'll run the application that has all the data. Maybe. There we go. And now we'll run the GUI. So if I set this to 2, ooh, this goes to 2. If I set this to 4, woo, that updates. So that's what's needed for some basic setup of a new behavior in the GUI. And let's purposely make this fail by putting some garbage in the name. And did I set the wrong property? So let's look at what's happening. This is actually good for, let's look at the debugging. These, of course, are all reentrant and dynamic dispatch. but you can go to the view menu, browse relationships, reentrant items, and let's see what's getting reported in here. So there is a that status is getting set. This says it's good. I should probably be returning this error out, and that would get caught elsewhere. But this is presumably failing, or that property doesn't do the thing I expect it to. So let's go ahead and close that. Let's get this closed down. I'm gonna have to close down the other application since they're all running in the same context. And well, let's propagate that error out. Oh, update value. And if nothing else, that'll give us a wire to probe. I could turn on... Actually, yeah, let me do that. That's not the one I wanted to close. I wanted to close that one. I can turn on the debug GUIs and have a pop-up, a window that shows with the event log. And there we go. So this is from the init. So we can see the double control init. I need to rename that. And then there's error 110. This is also, so this is an error somewhere else, but presumably, this property is not erroring, which means it's just not doing the thing I'm expecting it to. Yep. Okay. So we're getting some errors related to the fact that the name is garbage. We can clean up that second this 110 misleading error by not trying to subscribe if something earlier had an error. So this is failing. This is saying that that name didn't exist. That was at error 15. We shouldn't do all the rest of this stuff. How am I gonna organize this? Let's see, staleness we want regardless. In fact, I'm probably gonna move that underneath. And make a little more spacing here so I can get my case structure around these duders. Oh, that one we need. And let's propagate that error. We're going to need this to go do a little bit of a go around. So now we'll get rid of that error 110 because it's not going to try to subscribe to that garbage name. I'm actually, probably what I should do is make sure that channel exists at all. We can clean that up later and make this whole thing less necessary and get a less confusing error. Because the error is, hey, you tried subscribing to an invalid multicast address because I am not handling errors properly there. So that can just get fixed up. But it's using the default values, which is an empty string and a numeric value of 0 for the address and port. And of course, empty string :0. So just :0 is an invalid multicast address. Oop. I broke something. What did I break? Wire has loose ends. Oh, there's one little segment down there. Thanks for not getting rid of that before. And I guess go back to experimenting on a numeric slider. Is it housing? It's probably housing colors. Let's see if that's the one I want. Okay, so housing colors. Don't know what BG is, but that's not the one we want. So we'll go ahead and update that to housing color. Now, something that would probably be pretty good to do in a slider like this is set what we want the max and min for the range to be and make sure we get a good starting default value or like set increment or things like that. But I can also just set these in the GUI and not configure them and don't have to worry about overriding them. But okay, now should we get the highlight magenta? No! Oh, everything's stale. But why am I not getting... That background should be getting to stale. Got a whole bunch of errors because the... What do you mean unknown node? Oh. It's still not updating to pink. This should still be updating to pink. What's going on here? Uh, what color is that? Presumably this one. Yeah, that one. Oh, are the NXG controls in the modern not consistent with their properties? Is that what we're seeing here? Because that's valid. Not getting an error. Um, hooray. And then everything else is cyan because the other application is not running and publishing values. So that is expected. Let's replace you with NXG slider. Let's replace you with vertical pointer slide. Now I want to see black, magenta. Nope, nope. You start black. There we go. Blue's fine. There we go. Okay, so modern style and NXG style work differently. Hooray. That's all right. Should just be using NXG/fuse. Regardless, now if I start up the other application, all the other things start getting their values and the cyan goes away. But let's fix that name so this works properly again. And there we go. Hooray. And then if I shut down the other application that's generating the data, everything should go cyan. Or not. Fun. Oh, I don't have a staleness value configured. Blue, yay, there we go. And now I start up the other application. This is in its 10-second timeout for commanding. Normally in a commanding state, I'll change this backdrop color, and that actually should be happening. But theoretically, that'll revert to the other value. So, oh, I don't have commanding for this because the other one was meant to be just an indicator. So let's do that. So we'll add one more color selection. If it is currently in a commanding state, let's do a gray color. And perhaps something better to do would be like the text or the tick lines or something. Well, all right, we're going to leave that there. A little bit different. Because if you go to 100%, you're not going to see that status, but this should work for now. So you see that quick blink of gray, and then once a value comes back from the second application that matches what the command value was, it goes back into an uncommanded state. Cool. So that's it. How long has it been? An hour and 12 minutes. Oh boy. Okay, so about an hour with lots of talking and exploring and a little bit of debugging to do this. The idea is over time this gets simpler. Add more APIs in for the common behaviors, and but yeah, that's the idea. Is this is now pretty self-enclosed, and I get this fun behavior where there's no code running in this GUI, which I can't see while it's running. No code in this GUI, just the terminals, but can get some pretty complex behavior built into them without having to worry about what all the other GUI components are doing. So yeah, so if you have any questions, feel free to post them. This will be getting uploaded to YouTube, definitely longer form, but also kind of directives for coworkers or anybody else that are going to be trying to walk through this. Maybe I'll do a condensed edited version if that is requested. But the idea is you can kind of follow along with this process, get a little bit of understanding, and pause where you need to get through this. So if you made it all the way to the end, thanks for watching. I hope this application framework project is interesting to some people. It just recently this week rolled it out to a first test system at work, and it's got some teething pains on its first deployment, but it is very promising, and I'm having a lot of fun, and I'm excited to get to work in it. And I hope somebody else does as well. So thanks again for stopping by, and catch you later.